Another process is inner filter effect. I am not going in detail to the mechanism, and also there is another mechanism of electron transfer, and under this mechanism there can be fluorescence sensing, and there should be essentially a fluorescent probe with the help of which we can sense the concentration of the analyte. I am here giving you the detail of the protein, sorry, not protein, a dye, a fluorescent. It was invented by, or it was first reported by Adolf von Baeyer, a German chemist, and he coined the name fluorescent from fluo, and he was awarded the Nobel Prize in Chemistry in recognition of his services in advancement of organic chemistry. And this fluorescent, it was first used in 1877, major groundwater tracing experiment in Germany. You can see a figure here and a river. The results of this experiment showed that there are two rivers, and they are connected by underground stream. And fluorescent was placed in one river, and about 60 hours later, it appeared in the other river of Rhine. And it is notable that 10 kilograms of fluorescence was used for this purpose. So it is, I just mentioned this, some of the first earliest application of the fluorescent or some kind of fluorescent material for getting the idea that the two rivers are connected. Hope you have watched the slide and the river. So the important thing is the fluorophore. So what is the fluorescent probe? You can see here a number of fluorophores or probes used in this region, in this time being. There are quantum dots, chlorophylls, amino acids, fluorescent proteins, dyes, pigments, etc. They are used for analyzing disease or damage results, reaction kinetics, to explore the presence of explosives, some enzymes, temperature sensing, to know the chemical compounds present, and also some biopigments, biomarkers, etc. Among these quantum dots or fluorophores, quantum dots are more important due to this excellent quantum yield or fluorescence. Among these quantum dots, carbon quantum dots are now emerging as a good fluorescent probe due to the following qualities. It has tunable PL, stability, biocompatibility, etc. It can be used for bioimaging, solar cells, biosensing, cancer therapy, photocatalysis, etc. And And for biosensing also, these carbon quantum dots are using in wide extensively. And the biomarkers like cysteine, bilirubin, urea, uric acid, glucose, etc. are widely studied. Carbon dots are a kind of material. It's simply carbon. It's a fluorescent nanomaterial with size of less than 10 nanometers. They are known for their low toxicity, biocompatibility, excellent water solubility, etc. And a wide variety of synthesis method is analyzed and reported nowadays, like arc discharge, laser ablation, electrochemical approach, hydrothermal methods, and so on. And since it is simply carbon, it can be synthesized from a wide variety of green precursors, all kind of fruits, orange juice, lemon peel, banana juice, etc., and vegetables, cucumber juice, cabbage, etc., and some plants, tulasi, bamboo leaves, grass, and so on, and some from milk, yogurt, and others. You can see a wide variety of precursors here. All these are reported in various journals. And some chemical precursors are also used: citric acid, sucrose, uric acid, malonic acid, etc. And due to this low toxicity and good quantum yield, carbon content dots are used as a fluorophore from the long back, from 2012 to 2019, and it's going on. And we are the world scientists are exploring much behind the carbon dot. You can see a wide variety of applications here from C dots for analyzing various kind of biomarkers. Now, you can see the picture I shown in the first time of the presentation. You can easily understand the technique behind here. It is due to the fluorescence stiffness energy transfer FRET effect. There is carbon quantum dots and porous silicon. Two materials are there. And here silver and gold metallic particles are incorporated. I will tell what is the essential need for that. This is the material: carbon quantum dots, porous silicon, and gold and silver. And here, due to the efficient fluorescence resonance energy transfer, this material, that is this bimetallic carbon quantum dots, porous silicon, initially exhibit the silicon red fluorescence. Porous silicon is having red fluorescence, and carbon quantum dots is having blue fluorescence. So this blue fluorescence there is overlapping between emission of carbon QDs and porous silicon absorption. There is fluorescence quenching of CQDs, blue fluorescence. And upon oxidation, what happens is that this silicon red fluorescence is due to oxidation, this porous silicon fluorescence is decreasing, or its intensity is decreasing. So what happens? There is reduction in the FRET energy transfer. So due to this, there is increase in the blue emission of the carbon dots. And depending upon the glucose level in the sweat, there is production of H2O2 through enzymatic oxidation of glucose. This could change, or this could decrease the FRET effect between porous silicon and CQD, and this will result in the decay of the porous silicon red fluorescence. So initially the patch was red in color, and now with the introduction, or with the interaction with the H2O2 or hydrogen peroxide, the color changed from red to blue. I hope you understand the basic theory of the change in color. So by this we can probe the glucose in the body, and the color change from this red to blue depending upon the level of glucose in the body. So it is fine that there is no need of seeing the blood and all things, and it is very fine, it is user friendly, we can use it at home, we can see the change of color and see, yeah, I am diabetic, or there is some problem, I have increased my sugar level, like that. It is very user friendly to having such kind of fluorescence sensor. Here you can see the spectrum of absorption spectrum of that porosilicon, and also the emission spectrum of CQD. There is a good overlap between the two, and this leads to the threat transfer between the two materials. In the beginning I told there is also silver and gold. The need for that is, it is to give better sensitivity of the red emission of the porous silicon. You can see the figure here, the fluorescent emission spectra of porous silicon, and with addition of silver nanoparticles and gold nanoparticles. The black color emission was due to silicon, porous silicon nanoparticles. It has very much enhanced with the addition of bimetallic particles along with the porous silicon. Here we can see the pictures which changes its colors depending upon the oxidation rate. First it was red in color, and it is changing to blue color depending upon the oxidation of the porous silicon particles. And here in the next figure you can see the fluorescence emission spectra of the bimetallic carbon content dots and porous silicon particles. It's simulated wet aqueous solution with different concentration of the glucose. Upon addition of, there are a number of figures you can see here for different concentration of the glucose. 5 millimolar glucose, 9.5 millimolar glucose, 10 millimolar glucose. Upon addition of that much concentration, what happens here is that depending upon the time, the color is changing from red to blue, and it is very much explainable from this figure. Now coming to yet another application, it is ratiometric sensing, and this is similar kind of sensing as I told in the previous slide. Here they have used the carbon content dots in addition with gold. Gold is DSA stabilized AU nanoparticles, and with the addition of H2O2 that happens upon the reaction between glucose and glucose oxidase, and with the addition of H2O2, what happens here is that the emission spectrum, red emission of the gold nanoparticles is quenching, and the color is now turning to blue. So there is sudden transition from this purple color you can see here, the purple to blue, and this change in color can be related to concentration of the glucose. This is yet another report, and it helps to analyze the concentration of glucose in the sweat or blood. We can also prepare these solutions. With these solutions, we can also prepare some kind of paper or a paper kind of testing, and we can use this test paper for testing the amount of glucose present. We can also have, in the next slide is the work we are doing here in our lab. We have prepared carbon quantum dots, and you can see the blue sharp emission upon UV irradiation here, and we are also taking one natural dye that is having red emission, and both, with the help of both, we are analyzing the amount of sweat glucose, and that work is now going on here. And the thing is that here we are using the natural dye, and it is more good than a nanoparticle or a gold or silver, and it is more user friendly, it is more cost effective. So we are trying to build a fluorescent sensor in a more cost effective method. Now I will just mention some more applications. I'm not going into the detail, but I will just tell the applications of carbon dot in sensing metal ions. Some kind of metal ions are very much poisonous or toxic to humans. So it is essential to sense or to know the kind of metal ions or heavy metal ions present in water or present in some kind of fluids like this. Okay, so here I have listed 16 ions here. It is all reported that it can be detected by fluorescent emission change in the carbon quantum dot. This is yet another application where the carbon dot is used for getting the sun impression. You can see we are spraying the figure itself is narrating that we are spraying a carbon dot solution after drying, and upon radiating a UV light, we will get the sun impression. Okay, it is yet another one, another application, and it is so many applications of sensing are there. I have just put some or two applications for you to just know that it's a very vast kind of applications reporting, and it's very good, hot and active area of research. This is yet another application where you can see a blue emission of carbon dot, and upon depending upon the concentration of fluoride ion, it is very poisonous. It is present in some of the toothpaste and tap water, etc. So we have to analyze if it's present or what is its concentration, etc. And it can be analyzed with the help of carbon quantum dot, and it's depending upon the emission. With the presence of fluoride ion, the blue emission of the carbon dots are quenched, and the green emission of that molecule is regained. Okay, so that is also yet another application, and I'm not going into more and more. And but even though there are so many applications of fluorescent sensing and all, to make it into real point care devices, to make it into real sensing devices, there are many challenges. It is actually challenging to make a non-invasive technique. It has to be prepared as user-friendly, it has to be stable, and we have to enhance the selectivity, sensitivity, and we should have better limit of detection values. And there should not be any toxicity problem. It should be low toxicity. It should be long life. There should be shelf life, long shelf life, and it should be cost effective. So that are all many challenges behind it, and it is really hard to make this theory of fluorescent sensing of emission property and all, to make it into a real device or point care device. And if it is possible, it is now improving a lot in this in this time. And if it is possible, it is very easy, and that we can easily identify the glucose or ions, metal ions, when by using a simple paper tip or change in color. Like a pH paper, you all know, if the change in color indicates the pH. Similarly, just a paper strip with the change in color, you can, from the sweat, you can sense the glucose, you can sense the bilirubin, or you can sense some other biomarkers, creatine, uric acid, etc. You can easily sense, and you can check, are you ill or not. So that is very much important in this time. And now I am being time going on. I'm going to sum up it. The fluorescence spectroscopy is an effective tool for sensing applications, and with novel materials and enhanced selectivity, they can be employed in all type of sensors irrespective of the background. applications still continue to be challenging, yet implicit area to research upon. Thank you. If you have any questions, you can ask, or my email ID is here. You can just drop an email ID or just interact with me. Thank you a lot for listening me. Thank you.
Thank you, ma'am, for an informative session. Now it's time for open discussion. Participants, please post your questions in the chat box. If you have any doubts regarding the topic, please put your questions in the chat box. Ma'am, there is one question that the question is from Joel Jain Palakkulam. Is it possible to sense other bioenzymes also using carbon dots?
Yes, it is possible. Apart from glucose, you can sense other biomarkers. The thing is that there should be some interaction between that biomarker and this fluorophore. If there is some interaction, you can sense. No problem. There are many reports of.
Okay, ma'am. There is one more question. The question is from Saumya Mercy. Will this fluorescent spectroscopy give us clear results from any other test?
Yes. This fluorescence spectroscopy, it's actually simple and cost-effective method, and that is one of the challenges you have. Actually, it needs some that sensitivity and sensitivity that has to be done accordingly to get the better result. So many works are going on on fluorescence spectroscopy, fluorescence sensing, comparing it with available techniques now, and many reports. Even the glucose. I have shown one application, right? Glucose changing color from red to blue, and in that work they have done a lot of work that they have compared the result with the available techniques, and a good comparable results they have got. So it is possible, but it needs many input. That is all.
Okay, ma'am. Thank you, ma'am, for sharing your ideas. We are formally concluding the session. It's my pleasure to welcome Ms. Anjos M., Assistant Professor, Department of Physics, THRISSUR College, Guruvayoor, to propose the vote of thanks.
Respected Principal, Reverend Sister Dr. Varsa M.A., Guest of the Day, Dr. Anne-Marie K.A., Head of the Department, Dr. Hazel Matthew, my colleagues and participants of this webinar, good afternoon to you all. I know there was some inconvenience to all of you because of some technical issues in the beginning, but we managed it somehow. And we are very happy on the successful completion of our first attempt of conducting a webinar. We organized this webinar because of the energy received from the backbone of our college, the energetic, vibrant Reverend Sister Dr. Varsa M.E. On behalf of all of us, I thank our dear principal for supporting and leading us. Thank you. Next, I thank Dr. Anne-Marie K.A. for accepting our invitation to be a resource person of this webinar and for delivering such a fabulous presentation. Thank you, Dr. Anne-Marie. Next, I thank the energy of our department, our guide, Dr. Hazel Matthew, who is our constant. without whom this webinar may not happen. Thank you, ma'am. Next, I thank the person who worked hard to make this endeavor a great success. The coordinator of this webinar, Ms. Lali A.S. Thank you, my dear friend. Next, I thank all faculty members of the department and Mr. Bush Andis who provided technical assistance for us. Thank you all. But last but not least, I thank all the participants of this webinar who made this event a grand success. Special thanks for your patience and support. Once again, thank you all. Have a nice day.
Thank you, Ms. Ann.
Okay, thank you. Thank you very much.
Thank you, ma'am, for a wonderful session. And thank you to all the participants for becoming a part of our webinar. I'm sure that you have learned something new from this lecture. Thank you for your participation and involvement. Feedback link is put in the chat box. Only those participants who fill out the form will get the e-certificate. So thank you to all. Once again, session ends here. Thank you.
Thank you.